Welcome back my lovely viewers to my YouTube channel. So on today's video we'll be looking at vectors. So the question that is under consideration is states three forces: force 1 which is 100 newtons, force 2 which is 150 newton, and force 3 which is 120 newton acts on a 30 kg body as shown in the figure below. So the forces are 1, 2 and 3. So they want us to find what the distance. So how far does the body go in 2.5 starting from rest? So it started from rest. So the method that we're going to use is the resolution vectors to find what the resultant force. Yes, so that the resultant force that we use, because the one which we will determine, or is the one which will put this body into motion, is the resultant force. So we are going to find the resultant force, so that when we find the resultant force, because we have been given the mass and the time, so I think when we find the resultant force, we will find it. We can find the acceleration using Newton's second law of motion. So just try now to see what we can do. So to find the resultant force, we are going to find the component of each force that has been given. Let us start with it. So we can say x and y. Yes. So for force 1 is equal to 100 newton. So force 1 was along x-axis. So force 1 is along x-axis. So and when we said where the force 1 is going toward the x-axis, so this simply tells us that it is positive. So it is 100 newtons, and for y it is 0 because it is along x-axis. And for the second one, for the second force, is 150 newton. So in x-axis, using trigonometric identities, so using trig ratios, we can tell that in x-axis, because our force is here, we'll find that here it will be 150 cos theta, sine theta, and in here it will be 150 cos theta. Yes, same applies to this one. When we resolve it again, it will be like here it will be cos, here it will be sine. So let us try to see what we can do here. So here you can simply, in the simplest way, you can just write like so. It's just 150 cos the angle that has been given. Then we consider the angle counterclockwise, starting from this side, this point, to we go like this. So here we have what 30. This is equal to what we are going to find that. And for the y, it will be 150 sine 30, which is equal to, let's now try to see. Sine of 30 is 0.5, so 0.5 times 150, that is 75 newton. Then 150 cos of 30 is 129.9 against 0.4 newtons. And we go on the third force. On the third force, it's the third force is 120, and when we see the angle, our angle is here, but we should consider counterclockwise angles. So we are starting. So from here, our angle that we want to consider should start from here. This is the angle. So here we can just we can subtract To know this angle, we can just subtract 360 minus 20 to 340. That is the angle that we are considering. That is the angle that we are considering. So again, here we can say 120 cos 340. Yeah, cos 340, and 120 for the y. Maybe let me just put a demarcation here. 120 sine what? Sine 340. This now, yes, we can say now 120 cos 340. This is 112 point, you can just say 8. 120 sine 340, it's negative 4, 1.04, 0. Yeah, negative 41.04, yeah, rather. So we know that sine, because the angle is here, so sine here is negative. That's why this is negative. Now we are going to find what? The sum of all these forces and the sum of all these forces. So we are going to add. So I'll start from y. So we can say plus 75. This is giving me, then plus 0, that is just the same. So it is 33.96 newtons. And here it's 112.8 plus 129.904 plus 100. Oh, sorry, I think I made a mistake. 112.8 plus 129.904 plus 100. Yeah, should give us 342.704 newtons. Yeah, now we are going to find the what. From here we can find the resultant force. We can draw the graph of these forces. So we know that this is the x component. So x component is 342.704, and the y is here, which is 3.96. Now the one that we want to find is this one. This one is the one which we want to find. Again, here we can just use Pythagoras theorem, where we know that this is our r. So we know that r squared plus r squared is equal to x squared plus y squared. Yeah, so we are going to put in x, we have 342.7 squared plus 33.96 squared. This is our r squared. When we introduce the square root both sides, we find that this and this cancels, then our r will just be equal to the square root of 342.7 squared plus 33.96 squared. Here, from here you can just press on the calculator. Yeah, so here it's squared plus 33.96 squared, then the square root of that, then this is our resultant. This is our resultant force. So we can just round it off to 4 newtons. This is our resultant force. Then we have been told to find how far does the body go in 2.5 seconds starting from rest. So here we can use now the Newton's second law of motion to find, since we have been given the mass, we use the Newton's second law of motion to find our acceleration. So Newton's second law states like, yeah, this is what Newton's second law. Then we have our force, so we can make acceleration the subject of the formula. Acceleration will be equal to F over M, which is equal to, our F is 344.4 over, this is our mass is 34, so we are going to divide by 34. This is 10.1, I just round it off to 3 meters per second squared. Now that we have found this, we can use those four, just one of those four equation of motions equations. Yeah, so I think just looking at what we have, we can simply say x is equal to, we can use this plus half acceleration t squared. Since now it started from less, this is equal to 0. Now when we simplify our equation, we are remaining with this. From here we can just plug in what we have. Our acceleration is 10.13. Our time is 2.5 squared. This is equal to what? So we can say time divided by 2 times 2.5 times 2.5 to squared. That's why I've multiplied this twice. To 1.65, to 1.7 meters. This was our discussion for today's question. So thank you very much. If you have any question, you can drop it in the comment section. By God's willing, we can answer it.